Hi everyone, I am Jeyachandran J, Assistant Professor, Emmanuel Research JJ College of Engineering, Nattalam. Today I am going to teach you about the subject Computer Integrated Manufacturing, that means SIM. The term CAD/CAM refers to computer-aided design and computer-aided manufacturing. As its name implies, CAD/CAM uses the digital computers to aid the design and manufacturing process. In other words, CAD/CAM is concerned with the use of digital computers to perform certain functions in design and production. So, what is CAD? Computer-aided design. CAD is an approach to product and process design that utilizes the power of a computer. It involves the computers to create design drawings. So, using computers to create, modify and analyze, optimize a design, drafting, modeling and simulation. That is the key point of CAD. CAD means computer aided design. So, CAD may be defined as any design activity that involves the effective use of the computer to create, modify and or document an engineering design. CAD covers several automated technologies such as computer graphics to examine the visual characteristics of the product and computer-aided engineering to evaluate its engineering characteristics. CAD systems are powerful tools that are used in the mechanical design and geometric modeling of products and components. So, CAM means computer-aided manufacturing. Using computers to plan, control and manage manufacturing operations. NC part programming, that means numeric control, part programming and tool paths. The next one is CAD or CAM, that means integrated design manufacture. That means computer aided design or computer aided manufacturing. Direct link between design data and manufacturing processes, removing manual re-entry of geometry. That is the key point of CAD/CAM. And SIM means computer integrated manufacturing. That means the total integration of design, planning, production and business functions under unified computer control. The evolution of SIM involves SIM emerged through decades of incremental automation, each stage adding a new layer of computer control to manufacturing. In 1950s, the numeric control was introduced, so punch-type controlled machine tools automate repetitive machining. After that, 1960s to 70s, CAD and CAM emerged. Interactive graphics for design, CNC and DNC link computers to shop floor machines. Coming to 1970s to 80s, MRP or MRP2, that means material requirement and manufacturer resource planning, computerized production planning. In 1980s, FMS and robotics, flexible manufacturing systems and industrial robots automate handling and assembly. Finally, in 1980s to 90s, SIM concept formalized. That means design, planning, production and business systems integrated under one computer architecture. The figure shows the SIM architecture. The SIM wheel and manufacturing cycle. The SIM wheel SME model depicts manufacturing as concentric rings, strategy and resources at the center, supported by information systems and manufacturing processes. Strategy and resources includes the product process design, information resource management, factory automation, manufacturing engineering. That means the diagrammatic view of a SIM architecture. The manufacturing cycle involves marketing or order entry, product design, process and production planning, that means CAPP, manufacturing, that means CAM or CNC. CAM means computer aided manufacturing and CNC means computer numeric control. Quality assurance, the sixth one is distribution and field service. These 6 points are very much important in SIM architecture. Coming to the production system, production concept. The manufacturing systems are classified by production quantity and variety. This classification drives the choice of process, equipment and automation level. The first one is job shop production. Low quantity, high variety, general purpose machines, skilled labor are required in the job shop production. That means Q less than 100 units per year. That the Q where the Q depicts or Q indicates the quantity of the production. The key matrices are production rate RP, manufacturing lead time MLT, work in process WIP, plant capacity and utilization. So, the batch production includes medium quantity and variety that produced in batches or lots at intervals. That means 100 to 10,000 units per year. The final one is, or the third one is mass production. High quantity, low variety, dedicated equipment, flow line layout are included in the mass production. That is greater than 10,000 units per year. The production systems, the mathematical models for productions are included here. So each production or production time like that, production rate, plant capacity, utilization, have the equations to find out the mathematical models for the production. The quantitative models estimate production rate, capacity and utilization essential for planning and evaluating a manufacturing system. So first one is production time. That means TP is equal to TSU plus Q into TC. Setup time plus batch quantity into cycle time per unit. This is the equation to find out the production time. To find out the production rate, RP is equal to 60 divided by TP, units produced per hour from cycle time in minutes. So, plant capacity is calculated by the equation PC is equal to N into S into H into RP, machines into shifts into hours per shift into rate per machine. The utilization U is equal to hours used per hours available into 100%. Actual output versus maximum possible output can be calculated by using the utilization formula. The worked example is here. So the simple problem in production models illustrating the production rate model with the representative numerical example. So given batch size Q is equal to 100 units, setup time TSU is equal to 30 minutes, cycle time per unit TC is equal to 5 minutes. Here is a clear example to find out the production time TP and the production rate RP. So this kind of problem test direct substitution into TP and RP formulas covered on the previous slide. So here is a solution. We can find out the TP first. So TP is equal to TSU plus Q into TC. That means the substitution is only required for this problem. That is TSU is equal to 30 plus Q is equal to 100 into 5. That means 30 plus 500 is equal to 530 minutes. Then we can find RP is equal to 60 divided by TQ divided by Q. That means time per unit is equal to 530 divided by 100 is equal to 5.3 minute per unit. RP is equal to 60 per 5.3, that is equal to 11.32 units per hour. Result is TP is equal to 530 minutes and RP is equal to 11.32 units per hour. So coming to the system architecture, SIM hardware, the physical backbone of SIM, the machines, controls and material handling equipment that execute manufacturing operations. The first one is CNC machine tools. Computer controlled milling, turning and drilling centers are used in this type of CNC machine tools. Coming to the industrial robots, material handling, welding, assembly and inspections are used in this industrial robotic types. So third one is material handling system, AGVS, conveyors, ASRS for parts movement and storage. The fourth one is computers and controllers, host computers, PLCs and DNC systems linking machines, sensors and inspection equipment. That means CMMS, coordinate machining machine vision system, also the vision system and gauges for quality check. The final one is auxiliary equipment, tool changers, fixtures and work holding devices. Coming to the SIM software, software integrates and coordinates the SIM hardware, spanning design, planning, control and business functions like that. The CAD and CAE means that the geometric modeling, drafting, simulation and analysis. CAPP means computer aided process planning. Route sheets and operation sequencing are used in the CAPP system. So CAM and CNC programming includes both tool path generation and post processing for machines. MRP or ERP means that the material and resource requirement planning, enterprise wide integration. SCADA or MES, that means the real time monitoring, data acquisition and shop floor execution. Database management includes the central engineering and production database shared across the modules. So the major elements of a SIM systems are the 5 functional groups combined to form a complete SIM system spanning the full product life cycle from the marketing to service. The first one is marketing, the second one is product design, the third one is manufacturing engineering, the fourth one is factory automation, the fifth one is information resource management. These are the block diagram, these are the diagrammatic view of the major elements of a SIM system. That means the SIM system, in all SIM system, the manufacturing unit must be carefully managed according to the 5 major groups of functional groups that can be spanning the full product life cycle from the marketing to service system. Supporting the subsystems are order entry, forecasting and customer service. That means the marketing. CAD, engineering analysis and prototyping means the product design. CAPP, tool and fixed design, work flow planning, manufacturing engineering. These are the third block diagram design. For the CNC machines, robots, material handling and inspection, factory automations are included. The final one is database management, linking all functions in real time. That means information resource management. The 3-step process of SIM implementations are: first one is simplification, second one is automation, the third one is integration. Coming to the simplification, review and simplify the existing manufacturing process, eliminate unnecessary steps, rationalize product or process design before automating. The second one is automation, automate the simplified processes including introduce CNC robotics and material handling systems for individual operations. The third one is integration, integrate the automated islands via computer networks and shared databases, linking design, planning, production and business systems. The digital infrastructure of the computer and computer networks for manufacturing are the computer at multiple levels linked by networks from the digital nervous system of a SIM enterprise. The first one is corporate or enterprise host. Business planning, ERP, top level scheduling are included in the corporate or enterprise host. The second one is planned or area computers, production scheduling, MES, plant-wide database. The third one is cell controllers, coordinate groups of machines or workstations. Machine or device controllers means CNC, PLC or robot controllers at the process level. So the network, local area network, LAN or Ethernet for shop floor communication. MAP means the manufacturing automation protocol for factory devices. We can understand the enterprise WANs linking plans following the ISI reference model of interoperability. The future automated factory, that means the vision of a fully automated factory extends the SIM toward self-optimizing, minimally staffed, data-driven production. The first one is lights out manufacturing. Machines run unattended for extended periods with minimal human intervention. Flexible manufacturing systems. Rapid changeover between products via reprogrammable automation. Adaptive and intelligent control. Sensors and AI-based control adjust process in real time. Seamless enterprise integration. Design, planning, production and supply chain unified in one data model. The management and safety aspects of SIM. Our management of SIM includes strategic planning and justification of automation investment, change management, standardization of data formats across CAD, CAM, ERP systems, coordinating cross-sectional terms, design, production and IT, continuous performance monitoring and improvement, that is KPIs. Safety aspects of SIM includes machine guarding of and interlocks around robots and CNC equipment, emergency stop systems accessible at every workstation, safe zones or light curtains for human-robot collaboration, operator training on automated and network equipment, regular maintenance and electrical or fire safety audits. Coming to the advances in SIM, Industry 4.0 and the Industrial Internet of Things, IoT, connect machines, sensors and enterprise systems in real time. Digital twins simulate and optimize products and processes before physical production begins. AI and machine learning enable predictive maintenance and adapt schedule and quality prediction. Cloud and edge computing provides scalable data storage and near real-time shop floor analytics. Final one is additive manufacturing. 3D printing is integrated into SIM for rapid prototyping and low volume production. Thank you.